All right, class, as we continue working with roots, one thing we have to consider is what happens when a negative shows up. We've got a few examples here because depending on where the negative is and whether we're working with something like a square root or a cubed root, meaning whether the index, and by index we're talking about the number right there, is odd or even, it's going to inform how we actually solve the problem. So let's start off with an example here. We have negative square root of 16 over 25. Now, one thing you can do, being that the negative is out here on the outside, you're really going to treat this as if it doesn't exist for just a moment. Now, it terrifies me to say that because you could just drop the negative and forget it, and that's not what I'm saying at all. But let's just solve this first, and then we'll come back to the negative. We see we have a square root of 16 divided by a square root of 25. And so technically we could write it this way. When we see it this way, my hope is that you have learned your perfect squares and that you immediately recognize that both 16 and 25 are perfect squares. Square root of 16 is 4 and the square root of 25 is 5. So the square root of 16 over 25 would be 4/5. But then comes back to the negative, and so technically the answer would be negative. It's to be negative 4/5. The negative's on the outside of the radical. Okay, now remember the radical is this thing right here. The radicand is the number underneath. The negative is on the outside. So we take care of the radical, we solve or simplify as possible, and then we apply the negative to the result. So it's negative 4/5. Let's look at another example here. We have negative square root of 49 over 64. Now again, I could write it this way if I wanted to. I think sometimes this helps us to see what we're doing. And so the square root of 49 is 7. The square root of 64 is 8. And so that's going to be negative 7/8. All right, remember the negative is on the outside, so we deal with what's inside or under the radical first, and then we apply the negative. It's just that straightforward. Let's look at a couple of other examples. Now, in a previous video, I had mentioned what happens when the negative is on the inside. And so very briefly, we go back to our square example, and if we were to treat the area, we'll say this is a square, and we were to say the area is, let's just say, 16 centimeters squared. Well, what would be the side length? We'll call it S. What would be the side length? We know of a square, all sides are the same. So what the square root allows us to do is to take the square root of 16 centimeters squared, and the number times itself that gives us 16 is 4. We know it's a perfect square. Centimeters times centimeters is centimeters squared. So the side length, S, whoop, crazy arrow there. The side length is 4 centimeters. But now think about it. If I put a negative in there, the temptation is to say that the square root of negative 16 is negative 4. Because just like we did in a previous example, when the negative was out here, we just applied it to our answer. But that's not what we're doing here. Okay, so let's scratch that out. The square root of negative 16 does not equal negative 4. And here's an illustration as to why. If I want to work backwards, in other words, if I want to go from the root to the area, if you will, I would square the root right here, 4 squared, and that would give me 16. 4 centimeters quantity squared would give me 16 centimeters squared. All right? And so think about that. If I want to do the same thing here, I'm going to square it. Well, that's going to give me a positive 16. That's not negative 16. I hope you can see how that does not work. Negative 4 squared equals 16. So what's the point in all of this? What do we say to this answer? Well, it is not a real number. That's what we say in pre-algebra, and that's what we'll say later on. Now, later on in math, you'll see more about these negative square roots, but for now, we just know that it's not a real number. Okay, and so we call them imaginary numbers later, but when you see that, I don't care if it doesn't have to be 16. What if it's the square root of negative 81? All right, not a real number. All right, but what if the index What if this number is odd? Now that changes things. That does change things, because think about it. When I'm dealing with a cubed root, I'm wanting to know a number times itself 3 times, correct? Well, what happens if we just say, what is the cube root of 27? Well, that's 3, right? 3 times 3 is 9, and then 9 times 3 is 27. But what about the negative? What happens if I say, okay, what about negative 3? What about negative 3? Negative 3 times negative 3 is a positive 9. And then when I multiply it times a negative 3, I get negative 27. Can you see how it does work? I can take the cubed root of a negative number. I can't take the cubed root of I can't take the square root of a negative number, because a number times itself is going to give me a positive number. A negative 4 times a negative 4 is going to give me a positive. A positive 4 times a positive 4 is going to give me a positive. But it changes when I take this index and I change it to an odd number, because now you've seen this before. What's a negative times a negative? Well, it's a positive. But what's a negative times a negative times a negative? It's negative. In other words, that result, it can get me back to a negative number. So the cube root of negative 27 is, in fact, negative 3. So when you're dealing with an odd index, it does work. It can actually work. When you're dealing with an even index, like over here where we say, well, maybe that's a 2, that's not going to work. That's going to give us a non-real number.